Let's do some 6.7 day 2. So in this one, we've got a 20-foot ladder leaning up against a wall. The angle it makes with the wall is 22 degrees, and we have a distance on the ground from where the ladder touches to the wall. And what we want to know is, what is this distance? So if we call this height h, this distance d, and this is always going to be 20 foot, then if we relate something I know and something else I know to something I want, how do I relate two sides to an angle? Well, in this case, it's the opposite to the hypotenuse, so it's going to be sine. And so I multiply both sides by 20, and I get that 7.49 is about how long d is. So b is the original height of the ladder. And you get that the cosine of 22 is h over 20. You multiply both sides by 20. So you're going to get this 20 right here. And you end up getting 18.54 for the height, right? And so the new height of the ladder, here, this h new, this is what happens, that the ladder was here and then it slid down the wall, and now the ladder is here. The bottom has kicked out 3 feet further. So if this was 7.49 approximately, and it kicked out an additional 3 feet, well, now the distance from the base of the wall to the end of the ladder is 10.49. So if I want to know how high up the ladder is now, I can take 10.49 squared plus h new squared is equal to 20 squared and find that new height. When I do, using the Pythagorean theorem, I get that this is approximately 17.03. Well, that means I can take the original height of 18.54 and subtract the new height of 17.03, and I get this distance here, which is 1.5 feet, which is about how far the ladder fell when this bottom got kicked out 3 feet. It fell down about 1.59 feet. Next question, we've got a plane flying this way over an object at a height of 10,000 feet. 1 minute later, the plane is here. When it looks back at the object, the angle that it makes with the horizontal is 42 degrees, so now I have a triangle. Since the ground and the horizontal are parallel, cut by a transversal, if this is 42, then this is also 42 because they're alternate interior angles. So now you have a triangle, right? You could have also just drawn this height and had this triangle here if you wanted to, either one. So we now want to know what this distance is. So this distance d, if I want to relate this to this angle, it's its opposite over its adjacent, and we get this. If I multiply both sides by d, I get this. So my d distance is about 11,106 feet, is about how far it's gone. Well, notice that means we've gone 11,106 feet in 1 minute. So to change that to a speed in miles per hour, we multiply by 60 minutes over 1 hour, which is a well-chosen one. That cancels out our minutes. And then if I want miles, I multiply by 1 mile over 5,280 feet. That cancels out our feet. So we're just left with miles per hour. And it turns out to be, when we multiply all this divided by all this, we get 126 approximately miles per hour. Next, here is a mountain, and this is me going along the road. At 1 o'clock, I look up at the peak. Then I drive along the road. At 1:10, I look up at the peak. At 1 o'clock, when I look up at the peak, it is 10 degrees from the horizontal. That's my angle of elevation. And at 1:10, my angle of elevation is 70 degrees to the peak. So that gives us this height h. And now notice we've created 2 triangles. So here's a big green triangle with 10, 90-degree angle here, and this distance at the bottom. And then my orange triangle has a height of h and an angle of 70 degrees and this length. We have to give it a name, so we're going to call it x. So then when we look at our two triangles, first I need to find out how long this is. Well, since distance is rate times time, if our rate was 60 kilometers an hour and I go for 10 minutes, well, if I go 60 kilometers an hour, that's like going 60 kilometers in 60 minutes. The minutes cancel out, 60 cancels out, and I get that I've gone 10 kilometers. That's 10. This is, I just give it a name, x. So now, if I pull out my green and my orange triangles, they look like this. So there's my two triangles, and we're trying to solve for, let me go back and remember, we're trying to solve for how high that mountain is. Well, guess what? I've got an h here and an h here, so I'm going to make some trig functions, so some trig ratios specifically. So for this, its opposite over adjacent is its tangent for 10 degrees. And for 70 degrees, its opposite over adjacent is its tangent. So now I have two relationships for x and h. It's like two equations and two unknowns. I solve this for x and this for x. Why would I do that? Because then if these are both equal to x, I can set them equal to each other. And so you now have this. Well, what do you do once you have this? Well, minus 10 is the same as minus 10 over 1. So to add these fractions, I just multiply by tan 10 over tan 10 to get this. But then to combine these fractions, I guess I get this. And so now you will see that you have an equation only involving h, which we have to solve for. So since I have a fraction equal to another fraction, then I may cross multiply and get this. Now you see that I have h here and here, so I want to get all the h's on one side, so I pull it over here. And then I can factor out an h out of both of these terms and get this. And then I divide by what h is multiplied by, and I get this, which if you put it in your calculator, you get that. So that's the height of the mountain. We look here and we're just generalizing a question from before. If my height is c, I'm holding on to a kite. I want to know what is the entire height, how high up is this kite. If I've let out d amount of string, this is an angle of elevation alpha. Well, then we have this sort of a situation. So if this is h and this is c, then this distance right here would be h take away c is what that is. That's why I've written h minus c. This is d and this is alpha. And so if you want to relate things together, I can say that the sine of alpha is opposite over hypotenuse. I multiply by d, I get this. And if I add c, I find out that this is a way to find the height. If you know d, how much string you've let out, and the angle, and how tall you are, I can always find out how high up it is. Which is pretty interesting. Isn't that interesting? Look at this. It's the height, how high up my hand is, plus it's how much string you've let out, but it's the y part. It's the vertical part of how much you've let out. So it takes the vertical part of how much you've let out, which is what this is. Isn't that amazing? Awesome. So then we come over here to 63, last question. I've got a ship here and a ship here. One ship goes north, but 34 degrees west. So that means it tries to go north, but opens up an angle to the west of 34 degrees. The other one tries to go north, but opens up an angle of 56 degrees to the east. So this is our original port, and this is going straight north. So that means when I add the 34 and the 56, perfectly I get a 90-degree angle. And because of that, I have a right triangle. Why do I like that? Well, because the first ship, actually, let's go. This ship over here on the left, which was going west, was started at 1 p.m. and went till 3 p.m. So that's 2 hours. It tells us at a rate of 24 hours. So 2 times 24 is 48 is this distance. Well, then over here, this ship that was going northeast started at 1:30. So it went from 1:30 to 3, so it went for 1.5 hours at 18 miles an hour, so it went a total distance of 27 miles per hour. So now I've got a right triangle where I know two sides. To find the distance between them, I just use our old buddy, the Pythagorean theorem. And that's because it's a right triangle I can use it. And I get that the distance between them is about 55 miles per hour. Well, then it wants to know what is the bearing from this ship back to this ship. Well, anytime we want to know a bearing, we draw our little crosshairs. And we see that if we're going over here, we're actually going south, right? I'm going south, but then I open up some bearing away from south. So I'm actually going south, and this is the angle I need to know. Well, to get this part, again, I'm going south, but I opened up this much to hit this point over here. So to get this little piece, alpha, of my total angle, well, alpha is just the tangent, because it's a right triangle, would be its opposite over its adjacent. So it's going to be opposite over adjacent. This is going to be 27, excuse me. So it's going to be opposite over adjacent is going to be 27 over 48. So 27 divided by 48 is going to give me the arctan of 27 over 48, which is going to give me approximately 29 degrees. But then this little beta right here, since this is a right triangle, and you told me that this was 34 degrees, well, since at this port, make a little right triangle with my bearing, I've got 56 left over here. That means up here, this must also be 34, right? So when we add these two together, 29 plus 34, I get that my bearing, when I go south but open up this much, that this much is 63 degrees. So the bearing from the second ship, from the first to the second ship, from the first to the second ship, is going south but opening up 63 degrees east. And that's it. Have a great day. If I can